Good morning. I am Allison Cranford, and I am going to take you through your Eureka launch session for today. So I'm going to go ahead and jump right in, and because I don't want to run out of time as we go through and do this. Okay, so for our first task for today, we are going to multiply the numbers 15 times 13. And what I'm going to do is I'm going to multiply in a different way. So let me go ahead and get this set up real quick. I'm going to multiply the numbers 15 times 13 in this manner. So what I would like for you to do is go ahead and turn to an elbow partner and discuss, why am I multiplying the numbers 15 times 13 in this manner? You may begin. All right, volunteer to tell me why I did this. Okay, so what I'm hearing from you is that to multiply 15 times 13, you're going to write this as an equivalent expression, 10 plus 5 times the sum of 10 plus 3. All right, good. So we have an equivalent expression that we're seeing here. All right, so what you're seeing is coming from our story of units, okay? So this is our lower grade band. And what you're seeing is a way to multiply multi-digit numbers that teaches the multiplication algorithm to students. And it helps them to develop their understanding, a deep understanding of how to multiply these numbers. And it also helps to clarify the distributive property. And we'll see that a little bit later on whenever we get into the algebra and reversing the distributive property as well. So let's go ahead and write down what we got. So if you will grab your participant handout and look at part A, what I want you to do is go ahead and copy down this model that I have here, and then let's go ahead and fill in what our partial products would be here. All right, good. So let's go ahead and check and see what we got. First, you should have 100. Next one, 50, 30, and 15. Good. So again, these are the results of multiplying the partial products for each of my rectangles that I have here. So it's safe to say that 15 times 13, written as an equivalent expression, looks like this. And now we can just go ahead and add all of our partial products together, and we see that this is giving us 195. So the work with the concrete numbers that students are doing here in a story of units, it provides students with the foundation to do the more complex work that they're going to see here a little bit later on in a story of functions. So this is going to come into play when we do things like multiplying polynomial expressions. You're also going to see a change in the wording. So instead of calling it a rectangular array, we're going to move into calling this the tabular method. And there's reasons behind that, because whenever we get into the working with more complex numbers, we might have a negative here. And in the middle schools, you'll see the word area model being used, and that's not necessarily always going to apply. So we're going to move into calling this the tabular method. So what I would like for you to do, if you look at part B on your participant handout, we're going to use the tabular method to multiply x plus 5 times x plus 3. So go ahead and fill in the partial products. Go ahead and draw your model and fill in the partial products to multiply these two polynomials together. Okay, so let's see what we have. So our first box, x times x squared. There's those exponent rules that are coming back. All right, our next partial product, 5x. Our next partial product is the result of x times 3, so 3x. And then our last partial product is the result of 5 times 3, 15. Okay, so what I want you to do is take a second and look at the diagonals. What are you noticing here with your diagonals? All right, good. So you're seeing some like terms here. Okay, so this might look a little different than what you're used to, but we're going to go, when we talk about the diagonals, we're going to move from left to right and come down. So my first diagonal, if I were to add the like terms here, I only have an x squared term, so I'll write that there. Add my next diagonals. So this is the result of 5x plus 3x, which gives me 8x. And then my last diagonal is here, and it is the number 15. So we can say that x plus 5 times x plus 3 results in x squared plus 8x plus 15. Okay, so this is what I need you to do. Let's take a pause for a second with the math. Look at A and B, and I want you to look at what coherence do you see from part A to part B on your handout. Okay, good. So you're seeing that students are using the exact same model, a rectangular array. We're changing it to calling it the tabular method. All right, good observation. So somebody said that they noticed that the values here, the 5 and the 3 are the same. The only thing that we did was we went from a 10 to an X here, okay? So again, in those lower grades, they're working with numbers that are in base 10, and then as we move into algebra, we're changing up the base and calling it just X, and that's what a polynomial expression is. And so we are using the same numbers here, we're just changing up the base. Okay, so now what we're going to do is we're going to move in and look at part C. So for part C, what we want to do is we want to use the same model, but we want to factor trinomial expressions instead. So what I want you to do is turn to your elbow partner, and you're going to discuss how would you use this model to factor x squared plus 2x minus 15. All right, so I'll give you 1 minute to go ahead and talk. Okay, so if students were struggling with this, where can I get them started? Okay, so we can use the structure from before. We know that we have the sum of our partial products here, and we know from the previous example that we took those numbers and we had them along the diagonal here. So good, we can start by working backwards. So we know that this is x squared. We know this diagonal is going to give us 2x, and this diagonal will give us a negative 15. Okay, so what partial products do we know? Okay, we know x squared belongs here, and we know negative 15 belongs here. Good, so now we can kind of work backwards, and I'm going to put some blanks here, and we're just going to fill in the blanks. I know that this is the result of multiplying something here times something here. So what times what will give me x squared? X and x, good. And then again for this rectangle, I know that something times something is giving me a 15. And so we can kind of see in the previous structure that we were dealing with what numbers again? The 5 and the 3. 5 times 3 is giving me 15, but this is a negative 15. So then we're going to have a discussion about positive and negative integers. So you might want to come over here on the side and go, okay, I have a 5 and a 3, and it's resulting in a positive 2. So what number would be negative here? So hopefully our students are able to identify pretty quickly that the 3 would be negative. So I'll put my negative there. Let me come back in and do partial products just to verify. 5x, x times 3 is 3x, negative 3x, excuse me, and then if we add that together, we get a 2x. So we can say that to factor this trinomial, the equivalent expression would be x plus 5 times x minus 3. Okay, so hopefully going through and looking at your participant handout, looking at parts A, B, and C, you see a flow to the curriculum, okay? So A, we're learning a model in the lower grades that they can then apply here when they get to polynomials in Algebra 1. And then again, they can use that same structure that they just saw and used with polynomials to factor trinomials. So hopefully this has been a huge help for you today, and you see some of the importance of the lessons as we go through working through them in the modules and teaching them the way that we are describing. So thank you guys very much. Hope you have a nice day.